Now let's look at some application problems. These are the ones where I said you would have the formulas on the test, but it won't tell you how to use those formulas. And a lot of times the hardest thing is just figuring out which formula you need to use. So you need to identify different things in the problem and what they are, and also what the problem is asking you for. Here we've got a radius, so this would be the r. And we're talking about a wheel, and it's saying if it rolls 60 centimeters, that would be the same as an arc length. A distance in these problems is always going to be an arc length. And then what it's asking is how many radians it has turned through. Radians means it's asking about the angle, so it's asking for us to find theta. Now we can think about what formula has these three things in them. That would be the formula for arc length. That's S equals r theta. We're just going to plug in the S and the r, and we're going to solve for the theta. We can divide both sides by the 20 centimeters. And this is important to put your units in here, because what happens with this is that your units all cancel out and you just get a 3. If you get something with no units, then that's likely that that's going to be radians. And since we're talking about an angle measure, then we can say yes, that's radians. The answer to our question is that it has turned through 3 radians. In this one, we've got a satellite that's in a circular orbit. It tells us that the satellite is 6,000 miles from the center of the Earth. That's talking about a radius. We've got r equals 6,000 miles. And what it asks is how far does it travel? That would be a distance, so that would be an arc length. That's S. And it says it's sweeping out an angle of 120 degrees. The angle is going to be theta. That's telling us that the theta is 120 degrees. But remember, for these formulas, you almost always have to have the angle in radians. So we're going to have to convert this to radian measure, which would be taking it times pi over 180 degrees. This is going to simplify to 2 pi over 3 radians. What we're trying to find is the arc length, and we have an r and we have a theta. So we're back to this formula for arc length. We're just going to plug in the 6,000 miles and our 2 pi over 3 radians. If we simplify this, we end up with 4,000 pi. And our radians, remember, we don't really have to count as a unit, so we would end up with 4,000 pi miles. Now this would be the exact answer. If we were trying to find an approximate answer, we could just multiply 4,000 times pi, and this would give us 12,566 miles if we rounded it to the nearest mile. In this one, we've got a circular field, and if it helps you in these, remember, draw a picture. So we've got our circular field. It's being irrigated by the pivot sprinkler, which is going to be rotating around. We've got a radius of 240 meters. This again is going to be our R. It's asking for the area, which is A, and it tells us that it sweeps out an angle of 25 degrees. This angle right here is 25 degrees. That's going to be theta, only again we have to convert this to radians. We're going to multiply that by pi over 180 degrees. I'm not going to simplify this except to cancel out the degrees. Since I'm trying to find my area, there's only one formula that involves area, and that is 1/2 r squared theta. I've got the r and I've got the theta to plug in. If I just multiply this out, it comes up with the same answer we did in the last one, which is 4,000 pi, only this time the units are meters squared. If we want to do an approximation of this, it would come out to be 12,566 square meters. For this one, we're trying to find the linear speed. Remember that linear speed is the v. We've got a drum that revolves 52 times a minute, and we know the radius of the drum is 16 inches. We can say that r is 16 inches. This is actually giving us an angular speed. It's telling us the number of revolutions per minute. Remember, 1 revolution, when we're talking about angles, is 2 pi radians. Our angular speed, which is theta over t, is going to be 52 times 2 pi. That's our theta. Our t is going to be just 1 minute, since it said per minute. That's going to simplify to 104 pi, and this is going to be radians per minute. Now what we're trying to find is the v. The formula you'll get on the test for this is v equals s over t. Well, we don't have S, but we can also write this S as r theta, and we do have the theta over t. So we're going to take this part of it and replace it with the 104 pi, and then we know the r. All we're doing is plugging in the r and plugging in the theta over t that we found here. If we multiply that out, we get 1664 pi, and again we're going to forget about the radians, but we do have inches per minute. That would be our exact answer. Our approximate answer, rounded to one decimal place, would be 5,227.6 inches per minute. For this one, we've got a value for the radius, so we know that r is 14.5 centimeters. It says it takes 15 seconds, so that's a time t, for 40 centimeters of belt to go around the pulley. Notice this one is just a distance. There's no time related to it. It just has a unit of distance. So that's going to be an arc length. That's going to be an S. We've got those three things, and then it's asking us to find the angular speed. The angular speed is W, and that's theta over t. We do have the t that we could plug in here. We don't really have the theta, so we're going to have to find a way to find the theta. The other two values that we do have are r and s. And there is another formula we have that relates S, R, and theta, and that's this arc length formula. What we can do is plug in the S that we have and the R that we have. We don't know the theta, but we can solve this equation for theta. The units cancel out here, so we end up with no units, but that's okay. That's going to be radians. If we just leave this way, we can plug our values into this formula now to find the angular speed. So we have 40 over 14.5 radians, and our time was 15 seconds. That goes on the bottom. If we work all this out, we'll get an approximate answer of 0.1839, and our units that we'll have are radians per second.